Hello everyone. Today we are going to see conformal mapping. Take two curves C1, C2 in Z plane. Those two curves meet at the point Z0 and the corresponding curves gamma and gamma 2 in the W plane intersect at W0 by the transformation W equal to f of Z. If the angle between the two curves in the Z plane is same as the angle between the curves in the W plane, both in magnitude and in direction, then the transformation W equal to f of Z is said to be conformal mapping. The other way of defining this conformal mapping is a transformation that preserves angle between every pair of curves through a point both in magnitude and in sense of rotation is said to be conformal at that point. Next we are going to see what is isogonal transformation. The transformation which preserves angle between every pair of curves in magnitude and not in direction, that is sense of rotation, is called an isogonal transformation. Next comes the theorem based on conformal mapping. If f of z is analytic and f dash of z not equal to 0 in the region R of the z plane, then the mapping performed by W equal to f of z is conformal at all the points in R. So this is an important theorem to understand that the derivative of f of z not equal to 0 implies the mapping is conformal. Next comes the definition called as critical point. The point at which the mapping W equal to f of z is not conformal. Those points are called as critical points. That is, f dash of z equal to 0 at any point, those points are called as critical points. For example, take W equal to sine z. So f of z we are taking it as sine z. Find the derivative of sine z, which is cos z. Then equate to 0 and find out what is z. So if you equate this cos z to 0, you will get z as cos inverse 0, z equal to cos inverse 0. So for what are the values? What are the angles? Cos becomes 0. It is plus or minus pi by 2, plus or minus 3 pi by 2, etc. So in general, it can be written as 2n minus 1 into pi by 2, where n is an integer, which are all the critical points of the transformation W equal to sine z. So if we want to find the critical point, just find the derivative, equate to 0 and find the points which makes the derivative 0. Those points are called as critical points. Next, there are standard transformations called as translation, magnification and rotation, and inversion. These are the standard transformations we are going to study now. The translation is a transformation which is defined as z equal to z plus k, where k belongs to c. That is zw equal to z plus k, where k is a constant. So this mapping gives you a transformation of the image. Then next comes magnification and rotation. Here the transformation is w equal to k into z. So as k is real, you will be getting the magnified image. If k is imaginary, you will get a image with a rotation. Next is inversion. The mapping is defined as w equal to 1 by z. So we are going to see the transformations one by one with few examples. Consider the first example. We need to find a region of the W plane into which the rectangular region in the Z plane bounded by x equal to 0, y equal to 0, x equal to 1 and y equal to 2. This is the rectangular region. And we need to find what is the image of this under the transformation W equal to Z plus 2 minus I. This is the transformation is given. We need to find what is the image of the rectangular region defined here. So first we need to find what is the real and imaginary part of the analytic function. So first take w equal to z plus 2 minus I. Write w as u plus iv and z as x plus iy. Then separate the real and imaginary part in the right hand side. Equate that to the left hand side u plus iv. So you will get the real part u is equal to x plus 2 and the imaginary part v equal to y minus 1. Then after getting this, we need to substitute the rectangular region, edges of the rectangular region in this equation, and we need to find what is u and v. So if I substitute x is equal to 0 in this, I'll get u is equal to 2. Similarly, if I substitute y equal to 0 in v, I'll get v equal to minus 1. So likewise, I'll be getting the transformal boundary lines of the lines given in the problem. So for each and every x equal to 0, y equal to 0, x equal to 1, y equal to 2, I'm getting the images u equal to 2, v equal to minus 1, u equal to 3, v equal to minus 1. V is equal to 1 it is. So now we need to draw that and identify. Draw the rectangular region, given rectangular region in the z plane first. Take the coordinate axes as x and y. Y equal to 0 is x axis, x equal to 0 is y axis. X equal to 1 is a line parallel to y axis and y equal to 2 is a line parallel to x axis. Then this rectangular region should be shaded like this, and then the image of this rectangular region is u equal to 2, u equal to 2, draw that u equal to 2 line which is parallel to v axis, then v equal to minus 1 parallel to u axis, likewise u equal to 3 and v is equal to 1. So we are getting a rectangular region here, and if you see the image, it is moved from the origin to somewhere else. It is according to the transformation given, the image has been moved. So the transformation given here is a translation. So we are getting the image which is moved from the position which is touching the origin. Now in the image it is moved to some other. Next we are going to see magnification and rotation. So the transformation W equal to AZ will give you magnification or rotation according to what is the value of A. So if A is real, you will get a magnified image. If A is imaginary, you will be getting it as rotation. If A is both real and complex together, it will give you rotated and magnified image. We will take the example and understand this transformation W equal to 2Z. So from this transformation, you can easily understand the coefficient of Z is 2, which is a real number. So we are going to get a 2 times magnified image. So let us see the example. The region R of the W plane into which the triangular region D enclosed by the lines x equal to 0, y equal to 0, x plus y equal to 3 is transformed under this transformation. So we need to find what is the image of the triangular region whose edges are given here under this transformation W equal to 2z. So W you need to write it as u plus iv, z write it as x plus iy. Then separate real and imaginary part and identify what is u. U is 2x and v is 2y. Then we need what is u plus v also. So find u plus v, that will give you the relation x plus y. Then we need to find what is the image of x is equal to 0 h. So if I substitute that here, I will get u is equal to 0. Then if you substitute y is equal to 0 in v, you will get v equal to 0. Then if you substitute x plus y equal to 3, you will get u plus v is equal to 3 into 2, 6. So now we need to draw these lines in the W plane so that we can get what is the image of the given triangular region. So we can easily understand the magnification. So see this, the image or u equal to 0, v equal to 0 and u plus v equal to 6. So u equal to 0 is v axis and v equal to 0 is u axis, and u plus v is equal to 6 is the intercept form of the straight line equation. So if you see this, you can easily understand that the image is magnified 2 times. So w equal to 2z is the transformation which gives magnification. So next we are going to see the next example where the transformation is w equal to e power I pi by 4. So e power I theta, it is of the form e power I theta. It shows that it is a complex number. So you can understand that this transformation will give you a rotation and the angle is pi by 4. Okay. So upon seeing the problem, we can understand this. So we need to find what is the image of the triangular region bounded by x equal to 0, y equal to 0, x plus y equal to 1. the same triangular region which we have discussed in the previous problem, but the transformation is e power I pi by 4z. So now we need to find what is the real and imaginary part by rewriting what is this exponential term and what is z and what is w. So write w as u plus iv, z as x plus iy, and expand and rewrite this e power I pi by 4. So we already know e power I theta can be rewritten as cos theta plus I sin theta. Cos theta plus I sin theta. So therefore I can rewrite e power I pi by 4 as cos pi by 4 plus I sin pi by 4. Cos pi by 4 is 1 by root 2 plus I times sin pi by 4 is 1 by root 2 multiplied by x plus iy. So if you simplify this and separate the real and imaginary part, you will get the real part as x minus y by root 2, imaginary part as x plus y by root 2. So that you can easily equate this with u and v. So knowing what is u and v, now we can find what is the image of each and every edge of the triangular region. So when x is equal to 0, we need to find what is u and what is v. So u is minus y by root 2, v is plus y by root 2. So the relation between u and v is u is equal to minus v. Then when y is equal to 0, if you substitute here, you will get u as x by root 2, v as x by root 2. So both u and v are equal. So the relation between u and v is u equal to v. Then next we need to take this edge x plus y equal to 1. So if you substitute that x plus y equal to 1 here in v, you will get v is equal to 1 by root 2. Now we need to draw these edges in the w plane. So first we need to draw the given triangle in the z plane, x coordinate, y coordinate, x axis and y axis. Then y equal to 0 is x axis, x equal to 0 is y axis, x plus y is equal to 1 is a straight line whose intercept is at 1 on both the axes. So this is the triangular region given. Then a triangle given. Then we need to find what is the image of this. So image of that is u equal to minus v, which is a straight line passing through the origin, negative orientation. U equal to v is a straight line passing through the origin, positive orientation. And v is equal to 1 by root 2 is a straight line which passes through the point 1 by root 2 on the v axis. So the triangle, if you see the image, it is a triangle but it is rotated through an angle pi by 4, because it is a straight line passing through the origin which makes the angle pi by 4 with the u axis. So easily you can understand that there is a rotation happens based upon this transformation. So the region in the z plane is mapped onto the region in the w plane, and the mapping gives you the triangle and it is rotated through an angle pi by 4.